Thank you very much. I'm going to talk today about an outage that LinkedIn had in February of 2021, last year. I am not going to talk about last week's feed outage. I am not going to talk about last month's partial power outage. If you want to hear about those, you can ask me later when I'm not on stage. So anyways, first off, who am I? So I am with LinkedIn's Site Reliability Engineering team. It's actually part of site engineering. We've gone through a few changes over the years. I've been with the company for almost 9 years now. So I'm a principal staff engineer. I'm one of two within our SRE organization. Titles are difficult. For reference, engineering is something like 7,000 people, and I think we have about 60 principal staff engineers at this point. So we run a lot of large projects. Recently, my focus was on capacity engineering, testing applications in production for their capacity, automating capacity changes. More recently, I've been working on resilience and incident management within the company. So this is right up my alley right now. And then previous to that at LinkedIn, I was doing Kafka SRE. I co-authored the definitive guide for O'Reilly with Gwen Shapiro who was at Confluent and is now out on her own. And we have a couple more new authors as well, Krit and Rajani, who added on for the second edition. And as Dario mentioned, I run a lot of marathons. We actually met this morning at 6:30 in Dam Square with Dan and Todd Underwood, and we had a great run through the city. We had a tour guide literally run us around the city and got some great photos in the process. Enough about that. Let me give you a basic grounding of what incident management looks like at LinkedIn at the time of this event. And then I'll give you a little bit of an overview of what the site looks like how traffic runs through the site, and then we'll get into the details of the incident. So for terms, we call incidents GCNs. It stands for Global Change Notification. This is okay, so I have to be a little careful here because the guy who actually brought most of this into LinkedIn is sitting in the audience, and he's no longer my boss, so I don't really have to worry about it too much. So this is Global Change Notification. It's from a time at LinkedIn when every change was actually an incident anyway, so it just became the terminology for incidents. We have 3 severity levels for GCNs. A minor GCN really has very little impact on users, usually less than 1% impact or an internal problem. Mediums have about 5% impact on users, or deployment tooling went down in a site, or some other problem like that has pretty significant impact. And then we have majors. Majors are when the site goes down, when there's 30% impact to users or more, any sort of major problem. So this, of course, is a major incident for us. Then our tools. We run all of our incidents through Jira. We have a Jira ticket for every single incident. We have postmortem follow-up items. We have follow-up items for our daily meetings. We use Slack for most of our communications. As opposed to some other folks, we don't use Zoom for most of our incidents. We actually use Slack for just about everything. Zoom is reserved for the largest incidents when we really need face-to-face to get them resolved. So this one had a Zoom. Most of our major incidents have a Zoom, but not all of the mediums. None of the minors usually do. And then our follow-up items are all in Google Docs afterwards. And then for roles, we have our site ops team, also known as the NOC. They provide coordination for incidents. They help us get the right people in the room when we've identified who they are, make the phone calls, reach out to folks, help get us resources when we need them. We have communications role that's generally filled by a team called Prod SRE, which is closely aligned with site ops. They handle working with PR, notifying execs of changes that are going on. And then we have the on-call engineers who are involved in the role. You'll see something missing from this list. We'll talk about it later. So how does traffic flow into LinkedIn? I'm really sorry. I'm not an artist. I couldn't find the right drawing in a simplified enough way, but I'll go through this anyways and give you the heads up. So members come in through the internet, and all of our traffic comes into Azure Front Door POPs. That then flows into one of our data centers, and I've only drawn one data center here, but it comes into Apache Traffic Server. Apache Traffic Server has a bunch of plugins that it executes on every request, including calling out to our anti-abuse system to look up whether or not that IP address should be allowed, counts requests, and other things like that. And once that's all done, the traffic is then routed to the front ends and then further into the data center. This is about all that we really need to know for this particular incident. So what happened? What triggered this whole thing? We had been in a process of moving desktops to Azure. So like a lot of folks, we have Linux towers under everyone's desk so that all of our engineers would have a development environment that looks like production, makes it easy for them to make changes and get things tested before they actually check in the code and roll it out. We wanted to move those towers out of the buildings. They just caused problems. It wasn't really necessary. So we were moving them to Azure VMs. But the process was slow. We really didn't have much of a reason to push on it very hard until something happened. And then it became much more important. So as soon as the pandemic hit in March of 2020, we had this situation where nobody's in the office anymore. So they're not at their desks with their desktops. This makes maintenance difficult because nobody's there to power cycle boxes when they break. It also made facilities have a lot of problems because they're trying to clear out the buildings, clear out desks, and they have to work around these systems that have to stay there and have to stay online. So we accelerated the process of moving everything into Azure at that time. But we ran into a problem. As we were doing that in February, we realized there was a problem with one of the ACL systems. So people on the Linux desktop or on the Linux VMs in Azure couldn't access some of the internal tooling to deal with members. This is a simple change. It happens all the time. They were just coming in from a new IP address because there was a new NAT. So we realized we had to make a change to the anti-abuse list to add this new IP address. Here's where it gets interesting. Let's walk through what happened. So on this day in February, the ACL was updated at 10:46 in the morning. This is Pacific time. Within 3 minutes, there were reports of the site being down in Slack. It's not too bad. Not 5 minutes after that, there were reports of internal tooling being down in Slack as well. So at this point, the NOC is trying to get the incident started. It's already getting worse. Great. Didn't take us that much longer, only 6 minutes longer to realize that we had a crash loop going on in the Apache Traffic Server tier. And at the same time, the folks responsible for the anti-abuse application identified that there was a recent change to the anti-abuse list and that needed to be changed. This is all pretty good so far. We're only 15 minutes into the incident and we already know what's wrong. We have the right people in the room. This should be a no-brainer, right? This should be an easy fix at this point. It took us a little bit of time to actually work out what to do next. This was in part because a lot of the internal tooling was down at the time. So at 11:32, they started to shut down the ACL service that was serving this list. We knew that this was a safe operation. Apache Traffic Server could handle a failure of that request, and it would fail in a safe manner, or what we consider a safe manner. We have an anti-abuse, or an auto remediation system, rather, called Nurse that we use for automating actions on some of our applications. It had other ideas. It did what it was supposed to do. As soon as applications shut down, it restarted them. Very, very helpful. It took us almost another hour to shut down Nurse and get it to stop helping us. And then by 12:40, we were able to actually get the ACL service shut down and the site started to recover. So what did this actually look like in reality? That. You can see right after 10:45, as soon as that change goes in, the member traffic drops to 0. This is a graph of requests per second into the LinkedIn site across all of our data centers. It just drops out entirely. And then you can see at 11:30 where we start to shut down the ACL service and things start to recover, and then where auto remediation kicks in and complicates that process for us. The recovery is just off the side of this graph. So what was the root cause in this incident? Strike that. Root cause is a myth. We still use root cause internally. That's one of the things that's changing. But the thing is about incidents is it's never one thing. We heard this described this morning from Meta. It's always multiple things that were going wrong. There are multiple technical problems, there are multiple process problems, there are people problems going on. But the important part of that is that the human is usually the smallest part of any incident that's going on. They might be the trigger, but they're not actually what went wrong and what caused the incident to be quite so bad. So let's talk about the contributing factors for this incident, and there were many. The first one's the change process. So to update the anti-abuse list, you have to make a manual update to a JSON configuration in a web tool. There's no review process for this. The operator just sits there, enters in the change, clicks submit, and it goes out. The update that he entered in was missing a single comma in the list that he was adding in, and this was the trigger for our incident. Now, the reason it actually happened, the thing that let him make that mistake, is that the UI didn't validate any of the input it was getting. It didn't bother to check that it was actually JSON or anything else like that. There was reasons for this. That particular tool takes input in a lot of different formats. It's not all JSON. The application, the mid-tier that took the input from the UI and loaded it into the database, also did not validate that it was JSON. It just took the string from the UI and shoved it into Oracle, and everyone went on with life. Now, here's where it gets really interesting. This problem happened before. So we had this happen several years previous, and Apache Traffic Server validates this particular input to check that it is actually JSON and it can use it. But Apache Traffic Server had recently gone through a major version update internally, and there was a try-catch block that was left out around that check, which meant when the check failed, it threw a global exception instead of failing cleanly. Therefore, ATS was not validating that this input was actually JSON. So this is pretty bad so far. This takes out our public site pretty easily. But why did the internal site go down as well? Because we have separate tiers for Apache Traffic Server for external and internal traffic, and they have separate configurations. In this case, they were both loading the same anti-abuse list, even though the internal ATS tier did not need to load this list at all. They were both doing it, so they both crashed at the same time in the same way. And then there was no fallback in place either. Traffic Server started looping on its crash. It would load up, core dump, go down, and then load up again, and there was no stopping it. It and its infrastructure could not detect that this was happening and stop it and revert to a last known good state. All right, so now we've got our incident. Let's talk about how we made it worse. Let's talk about what went right first, because there were some things that went right here. The first one is our time to detection. It took us 3 minutes to know that there was a problem, and it took us 5 minutes to know that how big the problem was with our internal tooling. We could not have alerted on this faster than 3 minutes. Yes, it was a human that detected the problem. It was reported in Slack instead of through our alerting system. But in the best case, we maybe could have gotten an alert through a minute faster, and somebody would have had to see that alert and then respond to it. So 3 minutes is really good here. And we got it in Slack before anyone started complaining on Twitter. And they did start complaining on Twitter very quickly after that. But we, use all of our own tools internally. We're all on LinkedIn all the time, so we saw it very quickly. We identified the problem really quickly as well. It was 15 minutes from the thing happening to us knowing exactly why it was happening. So that's really good as well, because it takes you a while to get everyone together in the same room. Even that is going to take us 3, 4, 5 minutes past identifying the problem to get the people together. But we knew what the problem was. We knew what we needed to do. And the good thing is that our incident tooling really wasn't affected by this. We use Slack and we use Zooms. They're not internal tools. They're separate from our internal site, so we were able to keep using those without a problem. So we weren't hamstrung by not being able to execute on the process at that point. But there were a lot of problems, and it starts with too many cooks in the kitchen. And I apologize if this is a US idiom. There were just too many people and too much confusion going on. So the site's down. Nobody has anything to do. I'm sure some of those folks went out to get coffee, or they were playing with their kids, or doing something else. But there were a lot of people in Slack, and there were a lot of people in Zoom, including a lot of senior leadership within the company. And we have very technical leadership. So they're always very interested in what's going on, and they very much want to help with everything that's going on. And in a lot of cases, this is very useful because they've been there a long time. They know where all the strings to pull are. This is, useful information. It's useful to have someone who can drive that. But you also have a problem of there's too much direction at that point. Everyone has ideas how to fix this. Now, if the internal tooling hadn't been down, this would have been very quick to fix. We roll back the ACL update, everything comes back up, we move on with life. But because the internal tooling was down, everyone had thoughts about how to fix this particular problem and what we should look at next and what we should dig into. SSH was down because some of our SSH authentication went through the same internal tooling path. So we couldn't even take some of the basic steps we needed to try to fix the problem manually. We just couldn't get to the systems easily. And then we had no strong incident commander. Now, I mentioned this at the start that something was missing from our roles list, and that's the actual incident commander. Usually we just rely on the NOC to coordinate the incident, and someone will step in. Most of the medium incidents, it doesn't matter. We've seen this repeating pattern in our major incidents, though, where without a strong incident commander, there's nobody to tell those senior leaders to please be quiet for a few minutes and let the people who are involved work the problem and try to get through what they need to do. So this just creates chaos within the meeting. And I was in one recently where I walked into the Zoom for about 5 minutes, saw how many people there were with director, senior director, VP titles in the Zoom call, and I immediately left. I wasn't directly involved in the incident anyway, so I wasn't going to add anything to it at that point, but I knew what the problem was that needed to be addressed. The next problem we had was that we had no break glass procedures for a lot of our applications at this point. We didn't know how to fix the problems. And if this is difficult to read, this is a hammer for breaking glass, which itself is behind glass that is etched with "to obtain hammer, break glass," and underneath it says "toughened glass." So the UI that we enter the anti-abuse changes into had no CLI equivalent. So you couldn't get to the UI, you couldn't use a CLI to make the change. We couldn't update the database directly because we couldn't SSH into the boxes that we needed to because our authentication system for SSH used a path that went through Apache Traffic Server internally for part of it. So very few people had access to those hosts to get onto them. We didn't know how to shut down our auto remediation system. That was a whole other problem because it was being very helpful. We gave it a task to do, and it went and did that task. It restarted that application every time it went down in an effort to save the site. But we didn't know what to do at that point to fix it. We couldn't use the UI for the auto remediation system because guess what? It went through Apache Traffic Server like everything else. When we did finally get to the point where we manually disabled the plan for this application and thought we had solved the problem, we found out that there were duplicate plans for this application in the auto remediation system, which we would have seen if we were using the UI, but we couldn't use the UI, so we didn't know there were duplicate plans, so it took us a little bit longer to get that done, and eventually we just shut down the auto remediation entirely because it was easier than trying to solve this problem. But it really wasn't that easy because we couldn't SSH the hosts, and you see where this is going. Okay, so we did finally get this fixed. It took us an hour and 51 minutes to get the site, to get the problem mitigated. So our TTM was an hour and 51 minutes. It took us another 5 hours past that to actually resolve the incident. We had a lot of cleanup to do and other things to fix before we considered it to be done. And then we move into our post-incident process. So just like before, let's talk about what went right with post-incident review. We have a blameless culture, like a lot of us do. mantra that we adhere to is, let's attack the problem, not the person. I know who the engineer was who entered in this change, but I only know who it was because I was doing research for this talk and I dug into the original ticket to look and see what the entire timeline was. Their name was never brought up at any point during the post-incident review. It's not important. They weren't the cause of this incident. The process was the cause of this incident. Yes, the human made a mistake. Humans make mistakes all the time. Computers make mistakes too, but they're at least mistakes that humans told them to make, even if they think they didn't. It was the process that failed. It was the process that allowed that human to make that mistake in this case. So we don't care who the human was, and we had a good review of this entire thing. So let's go into what we did to fix the technology first, because fixing technology is really easy. Start with Apache Traffic Server. We fixed the isolation problems. We went through and audited the configurations to find all the places where we thought it was supposed to be isolated, and we actually isolated those two tiers so they won't load the same configurations, and we can't trigger this problem in both external and internal systems anymore. We fixed the validation bug in Apache Traffic Server, added a unit test for that because the unit test was also missing, which is how we didn't see that the try-catch was missing, and then went through the code where we did that major version update to find all the other places where we had left out things in Apache Traffic Server, like the ability to detect that it was in a crash loop and revert to a last known good state. And then we added more monitoring for configuration validation errors so that now that we've got all this fixed, we know when it's actually a problem and we can get back into it. We added change validation. The update process for the allow list changes that we were dealing with in the ACL app, we now have a process for review. So it's not just open a JIRA ticket, it gets reviewed in the JIRA ticket and then entered in. The engineer entering it in needs to go through a review as well. We added format checking in that application as well as others so that when you enter in JSON, you actually enter in JSON and not something else. And then we've defined the break glass procedures for our auto remediation, and we've also made it follow the deployment pauses. So we have a system in place that we can pause any application or the entire site within the deployment system. We used this just last week when we had an internal conference and we froze all the deployments on the site so that the SREs could actually concentrate on the conference and not on the site. But this system did not follow that, and I will mention that feed outage was because we had a system that didn't follow deployment pauses and allowed a manual action to happen, but that's a whole other talk. So the technology's fixed. That's fine, no problem. Let's talk about the people. The people are much harder. The first problem is our process around incident commander. So we thought we had people who could be incident commanders for major incidents. Our prod SRE team was supposed to fill this gap in the process and provide that direction while they were doing the communications as well. But what we found is that most of them were not comfortable interacting with senior leadership. It really does require a certain skill set, the ability to tell a senior director or a vice president to, please just wait a minute, we'll get you the information you're looking for. We need to work through this problem and get them out of the way of the process. So what we're going to do is we're working on creating a rotation of senior leaders to run the largest incidents, ICs and managers who are at a certain level and we feel can do this. Now, you'll notice a problem with this statement. The problem with this statement is that we're using the criteria of senior leadership to determine who should be doing this. It's not a great criteria because that doesn't equate to the skills to run an actual incident. But to start with, it's the best proxy we have without introducing more training and more problems into the process. So we're going to use that rotation to have another group of people shadow those leaders as they're going through the incidents to see how to interact at that level and learn that process by doing it. This is something that's in progress right now. We were talking about this yesterday. We've been working on it since last year, but there have been several other things that have been going on that have taken priority in this process. So we've seen this happen, though, again and again in major incidents, and it's become far more important as far as prioritization goes. So this is the first thing that we're working on. The next is looking at an overhaul of our entire incident response process. I'm specifically not going to look in this direction right now while I'm doing this. So our process is very old. It's grown up over the years that we've had SRE, and it has served us very well over that time. Like, we solve our site issues very quickly. We know how we're doing things, but we're also in a process right now of moving on call from just SRE to all of engineering. So we're moving from a place where the audience for incident response has been 600, 700, 800 people to a place where it's now going to be an audience of 7,000 people. And the dynamics are different. The engineers who are going to be on call for their applications don't have the systems level knowledge that SREs have. So they're looking at their application, and we need to bring in an easier process for them to work with, and we need to have more structure around it, not only the incident commander role, but also other roles, and have them be well-defined in the entire process. So that's where we're headed right now. We have a lot of unwritten knowledge that's present in the incident management process as well. SREs do it because they know how to do it, and they know how to do it because they've done it, and they've done it because it's just what they do. But we don't write it all down. Where it is written down, some of it is very hard to understand, and that's going to cause problems for all of these other engineers coming into this process. And then we have not great follow-up and analytics on our incidents afterwards. We do a postmortem. Yes, we still use the term postmortem. We're going to be transitioning that over time as well. We do follow-up items that are in JIRA and are tracked. A lot of times those follow-up items aren't acted on, though. They're cleared out a year later when everyone's forgotten about them and we move on with life. And we don't do a lot of analytics or deep analysis as to what the patterns are in our incidents that are going on. We do that post-review. We fix the problems in the application, and sometimes we identify larger problems that need to be fixed as part of that, and we go on. So what are we doing to fix this? What does the future of incident response look like for us? The first is that we're looking to create a dedicated team for incident management. Now, we've heard this from a couple other folks here. The gentleman from Twilio yesterday mentioned that they have a centralized incident management process. We're looking at the same idea, having a central team that will have the incident commanders for the largest incidents. We'll also be responsible for defining the process, maintaining the documentation, following up on the post-review items, doing the analytics, all of these other things that are going on. We're also looking at creating a single flow for incidents that doesn't use JIRA, because JIRA is not built for this and it doesn't do a great job, and nobody really likes JIRA anyways, but we all have to use it. So we're talking to several vendors, not all of whom are up here. We're also looking at whether or not we should be building it ourselves, but this is one of the cases where we're actually looking at buying in a solution. This is a new thing for us. You know, we're LinkedIn, we're a big SRE organization. We build a lot of tooling. We like building our tooling, but we're looking at buying here because this isn't core business for us, and we want to be efficient about what we're doing. So in a number of different ways, this process is going to be new for us. And then we're looking at doing deeper analysis on all of these incidents. We've started this already. We have a new incident review meeting that meets every week to pick out a couple of incidents that are particularly interesting and go deeper than the post-incident review did on them to pull out patterns in those incidents. So particular areas such as we're using feature flags and to lock out certain sections of code in applications. And when they're 100% ramped, that if the feature flag system goes down and the old code path isn't any good, then things crash because they're not resilient. So we should really look at that holistically and fix it across the entire organization. So these are the types of things that this deeper analysis is now pulling out of our incidents. And that's really it. I mean, that's what we're moving on to now. And really thank you for your time and letting me talk about this. I love talking about when things break.